Now we're going to talk about the inverse tangent function. So just like sine and cosine have an inverse, tangent has an inverse as well. We will do the same thing with tangent that we did with sine and cosine. Because there are so many pieces of the tangent function, it is not one-to-one and will not pass a horizontal line test. So we restrict the domain to this center piece right at the origin. We restrict the domain from negative pi over 2 to positive pi over 2, and therefore it is one-to-one, and we can talk about it having an inverse. And so here's what the graph of the tangent inverse function would look like. I want to remind you there is an alternate notation or terminology that we use. If you see arc tangent of x, it just means tangent inverse. We can see that we have these side ratio values along the x-axis. We have the angle measures along the y-axis. So we are definitely talking about swapping the domain and range for tangent and tangent inverse. So just like we did for the other trig functions, the domain for tangent of x would be an angle measure, where the range would be a side ratio, the side ratio that we get from those triangles. And then for the inverse function, tangent inverse of x, the domain is therefore the range of the original function. So we're going to put side ratios just like sine and cosine, and that's going to map us back to our angle measures. And we're going to have to make sure that we pay attention to the fact that our domain is restricted to negative pi over 2 to positive pi over 2. So the domain for the tangent function is all real numbers. If we reflect that over, actually if we reflect this graph over the line y equals x, then that piece has a horizontal asymptote at pi over 2, another horizontal asymptote at negative pi over 2, and this goes on to positive infinity, and this goes down to negative infinity. So the domain for the tangent inverse function is negative infinity to positive infinity, while the range is restricted from negative pi over 2 to positive pi over 2. So now that we understand that we can have a tangent inverse, let's work some tangent inverse problems. So again, we have restricted our domain. We want to ask ourselves, for what angle measure, the tangent of what theta, did we get square roots of 3 for an answer? So let's go here. Let's go back to the unit circle. We are restricted to negative pi over 2 to positive pi over 2. So we can only look in quadrant 1 and quadrant 4 for the answer to this one. And we know that square roots of 3 is going to show up whenever sine was square roots of 3 over 2 and cosine was 1/2. I think I should say sine inverse and cosine inverse, right? That's the angle measure that we're looking for, because this algebraically simplifies to the square roots of 3. So I want to know for what angle measure was sine square roots of 3 over 2. That happened here at pi over 3. It also happened here at 5 pi over 3. That's where if we dropped our triangles, that's where the y value was larger than the x value. So the coordinates of this point at pi over 3 look like that, and the coordinates here have a negative y value. So that knocks 5 pi over 3 out of the running, even though it's in this interval. So the tangent inverse of square roots of 3 has to be pi over 3. That's the only angle measure on that interval where tangent could have been the square roots of 3. So you can see it's identical to the work that we did for sine and cosine. So let's work here with this problem. Remember, we always start inside. So I'm going to start by finding the tangent inverse of 1. Tangent can only be one where sine of theta and cosine of theta were the same value. They have to be the same value because anything divided by itself equals 1. We know in the unit circle, sine and cosine at iterations of pi over 4 had the same value, root 2 over 2 and root 2 over 2. Again, down here at 7 pi over 4, they had the same measure, but the y-coordinate is negative, and this is not asking for the tangent inverse of -1. Remember, we are restricted to negative pi over 2 to positive pi over 2. Those are the only two quadrants we can look in. So this angle measure has to be our answer. The tangent inverse of 1 is pi over 4. So now what's inside here is equivalent to pi over 4. We're going to plug that into the cosine function machine, and the cosine of pi over 4, we can see right here, is root 2 over 2. And that's it. There's a couple of examples. I think it works and follows well from what we did with sine and cosine, so I don't see the need for a whole lot of more examples. Come to class next time and we'll work some tangent inverse problems.